Welcome to the deep dive. Today we're getting into something really on the edge, meta AI systems.
Yeah, it's like the next big step, isn't it? Not just one AI, but whole teams of them.
Exactly. Complex, adaptive, all working together. You know, when you think about really advanced AI, maybe like a Compare or Hypersia systems, needing amazing coordination, self-awareness.
Right, and that complexity, that's the fascinating part. It's not just about one smart component
But
anymore.
it also brings up huge questions, doesn't it, for anyone listening?
Mm.
How do we make sure these things are reliable?
Yeah, effective. And the big one, can we actually trust them? Especially when they're so intricate.
Precisely. And that's what we're diving into. We're zeroing in on this foundational idea, computational metacognition.
Okay.
For you, the listener, wanting to grasp AI's future, this is key. It's about giving AI a kind of self-awareness, thinking about its own thinking.
Evaluating itself, spotting problems proactively,
Yeah.
understanding itself from the inside, really.
So looking at the big meta-AI picture, computational metacognition is like the internal supervisor.
That's a good way to put it. It's the AI monitoring and managing its own cognitive processes, not just reacting to the world.
Mm-hmm.
And the research we've looked at really hammers this home. It sees this metacognition as, well, absolutely central to pushing meta AI forward.
Okay, so let's unpack that core idea then, computational metacognition. In an AI context, what is it really?
Well, basically, it's taking ideas from cognitive science, about higher order thinking.
Like how we think about thinking.
Exactly.
Yeah.
Applying that to AI. The crucial part is the AI monitoring and controlling its own internal stuff, its operations.
So not just sensing the environment, but looking inward at its own processes.
Precisely. The goal is to make its thinking better, so its actions, its task performance improve.
So if I reflect on how I solved a puzzle,
Hmm.
the AI does something similar internally.
Yeah, pretty much. And the sources say this often means the AI explicitly represents and tracks its own cognitive steps.
Yeah.
And this ability, this self-awareness, it's seen as a huge leap towards AI that really mimics the more complex parts of, human intelligence.
A real differentiator.
Definitely. Sets it apart from simpler machine learning.
This is where it gets really interesting for me. How are people actually building this self-awareness into AI? What kind of models or blueprints are they using?
So the research talks about these things called computational metacognitive architectures, CMAs.
CMAs.
Think of them as the frameworks for modeling and processing the AI's internal cognitive life, like its own mental diary, sort of.
Right.
Now, one challenge is that CMA research is quite fragmented right now. Lots of different ideas, terms, makes it hard to see one single path emerging yet.
Sounds like a field that's really buzzing with exploration then. Any specific examples of these architectures that make it clear?
Oh, absolutely. One they highlight is MIDCA, Metacognitive Integrated Dual Cycle Architecture. The key idea there is taking the usual action perception loop and turning it inward. So instead of just acting on the outside world, it cycles through the system's internal mental state.
Interesting. So it's perceiving its own thoughts.
In a way, yeah. Then there's C4, modeling content-centric computational cognitive.
C4.
What's key with C4 is the link they're trying to build between self-awareness and the AI's ability to explain itself in ways humans get.
Explainability. That's huge.
Totally. And it uses these structured knowledge things, ontologies, to help guide its self-reflection.
Ontologies. So those are like detailed knowledge maps, right? For understanding concepts.
Exactly. Gives it semantic understanding it can use to reflect more deeply. Then there's this EDCR framework, error detecting and correcting rules.
Yeah, EDCR.
The neat thing about EDCR is it tries to quantify the benefit of metacognition. It learns rules to fix errors, say, in perception.
So it measures the improvement.
Yeah, and it even offers a mathematical basis for understanding when and how much metacognition helps. And finally, for folks familiar with LLMs,
Large language models.
yeah, there's the MECO strategy, pretty clever. It uses the LLM's existing internal signals to figure out when it needs help, like using external tools.
So it's like a built-in self-assessment for the LLM without needing huge retraining.
Exactly, a proxy for self-assessment.
Wow. Okay. A real range of strategies tackling it from different angles. Now, this metacognition, is it just one thing or are there different kinds?
Good question. The research breaks it down based on timing and purpose. First, there's explanatory metacognition.
Explanatory. Sounds like looking back.
Exactly. Reflective, backward-looking. It kicks in after the AI messes up somehow. made a wrong call, failed a task.
The postmortem.
Right. The AI asks itself, okay, why did my thinking go off the rails there? It compares expected internal process with what actually happened.
And if there's a mismatch.
A metacognitive expectation failure, they call it. Then it tries to diagnose the cause, maybe using past experiences like case-based reasoning, and sets new internal goals to avoid it next time. It's AI learning from hindsight.
Okay, so even AI needs hindsight. What else?
Then there's immediate metacognition. This is more real-time, like on-the-fly control of thinking as it's happening.
Like a self-driving car constantly adjusting.
Kind of, yeah. Managing limited resources, maybe, or adjusting plans mid-task. Though the sources we saw admit the detailed mechanisms here are, well, less explored.
Still a bit fuzzy. Got it. And the last one.
Anticipatory metacognition. This one's forward-looking. The AI makes judgments about how well it thinks it'll do on a future task.
Predicting its own success.
Yeah, or failure. And if it anticipates trouble, maybe it lacks data or something, it might decide, okay, I should delegate this.
Delegate to another AI.
Right. Which is interesting because that needs the AI to reason about other agents' abilities. Touches on something like theory of mind.
Wow. Okay, so reacting, learning from the past, and predicting the future, that sounds much more sophisticated. Now, the outline mentioned AI introspection. How's that fit in?
Introspection is super closely related. You could think of metacognition as the big umbrella of self-awareness. Introspection is a key mechanism under that umbrella.
Okay.
It's about the AI system looking at its own internal states, its processes, and this is absolutely fundamental for trust, which brings us to explainable AI, XAI.
Right, because we need to know why it made a decision.
Exactly.
And there are different flavors of these introspective explanations.
Yeah, the research points out a few levels. There's introspective tracing. That's the super detailed step-by-step log of the AI's reasoning.
So a human could follow the whole path.
Pretty much. Great for debugging, accountability, but maybe harder with some types of machine learning.
Like black boxes.
Right. Then there's introspective informative. This gives enough info to convince someone the decision was okay or help spot an error, but maybe not every single detail.
More of a summary.
Kind of. And lastly, post hoc explanations, rationalizations.
Oh.
Yeah. Generated after the decisions, sometimes by those black box models. The risk is they might not be accurate, might not reflect the real reason at all, could be misleading.
So tracing is better for real understanding. But introspection isn't just about explaining, right? It helps AI learn, too.
Definitely. The sources mention how, like, if an AI hits a question it can't answer, that can trigger introspection. Why don't I know this?
So the gap triggers learning?
Exactly. It might lead to seeking out that missing info. Plus, during training, you could have a teacher AI guide a student AI using its own introspection.
Like giving advice based on its own internal checks.
Right. And fundamentally, researchers talk about positive introspection, knowing what you know, and negative introspection, knowing what you don't know. Both are crucial for robust reasoning.
Knowing your limits. Okay, so we're seeing how AI can look inward, understand its thinking, learn. But what are the actual mechanisms doing this, enabling self-awareness, self-evaluation?
Several key ones being explored. One is self-modeling and representation.
Self-modeling.
This goes beyond just introspection. It's the AI building an internal model of itself, its identity, its mind, its history, even its social context with other AIs.
A model of me for the AI.
Sort of, yeah. This could really improve interaction, make behavior more coherent. They even mention robots learning self-models just by interacting, not by being explicitly programmed with one.
That's kind of mind-bending, an AI figuring out who it is.
It is profound. Another related idea is the cognitive sense of self. This pulls from cognitive science, neuroscience. Can AI emulate human self-recognition, reflective learning, identity over time?
Looking at how humans do it.
Yeah, thinking about embodied cognition, our sense of self tied to our body, even looking at brain areas like the insula, involved in internal body sense.
But crucially?
Crucially, this is about functional self-models capabilities, not genuine consciousness or subjective experience. That's a whole different kettle of fish.
Right, very important distinction.
Oh.
Okay, so stepping back from the theoretical, what are some practical bits and pieces for self-evaluation?
Lots of concrete techniques. Chain of thought analysis, COT.
CT, UT, yeah, we hear about that with LLMs.
Exactly. Get the AI to articulate its thinking step by step. Makes it transparent for analysis, finding flaws. Often involves prompting maybe a second pass where the AI critiques its own first answer.
Checking its own work.
Then, error identification mechanisms. Systematic ways for the AI to spot inconsistencies, things that seem wrong.
Like internal quality control.
You could say that. Techniques like self-consistency checks, try solving it multiple ways, see if answers match. Or retrieval augmented verification, check claims against outside knowledge, even tracking its own uncertainty levels.
Smart. What else?
Self-reflection. This is the AI critically analyzing its own outputs, reasoning, decisions, aiming to find limits, errors, biases so it can improve.
Learning from mistakes.
Right. Often uses multi-stage processes, maybe guided by rubrics, questions prompting evaluation of accuracy, coherence, stuff like that. Feedback loops are key here.
Using the evaluation to get better next time.
Absolutely. And we're seeing general evaluation frameworks emerge, too. Structured systems to rigorously test AI, clear goals, diverse data, multiple metrics, ongoing monitoring, often human oversight.
Like standardized testing for AI.
Kind of. Even LLMs are being developed to do self-evaluation using objective metrics, user feedback, tracking their own confidence and errors.
It's like they're constantly taking their own temperature. You mentioned behavioral self-awareness in LLMs and robot self-awareness capacities, specific examples.
Yeah, they show how these ideas play out. Behavioral self-awareness in LLMs asks if models can grasp their own learned tendencies. Like, does it know it tends to be bold or produce insecure code?
Can it describe its own personality almost?
Some research suggests yes, they can describe and even quantify these tendencies, like self-perceived risk tolerance. Pinpointing exact triggers is harder, though.
Still tricky. And robots.
Robot self-awareness research often looks at self-evaluation, knowing that I know, understanding its own abilities in a situation, and meta-reasoning, thinking about its own thinking and goals.
Okay, this really points towards more autonomous, self-managing AI. How does this metacognition lead to proactive issue identification?
Well, that's the payoff, really. By analyzing past failures, evaluating current performance, the AI can start to anticipate problems.
See them coming.
Exactly. Predictive AI techniques use historical data, real-time metrics to forecast trouble performance dips, failures. Anomaly detection spots weird behavior.
Early warnings.
Right. Proactive threat detection and security uses rules, patterns to find attacks, trigger responses. Some systems might even have self-healing capabilities for minor glitches.
Fix it themselves.
And even proactively requesting permissions or resources they think they'll need later instead of hitting a wall.
So not just reacting, but actively preventing problems. That sounds vital for these complex meta-AI systems. Okay, pulling it all together. What are the big implications for meta-AI from all this metacognition research?
I think the clearest implication is that for these really complex systems, it won't be just one metacognitive trick.
No silver bullet.
Probably not. Given all the approaches, symbolic trace analysis, probabilistic reasoning, LLM checks, knowledge-based stuff, robotic self-evaluation, it's likely going to be a hybrid architecture.
Mixing and match.
Exactly. Applying different methods to different parts of the meta-AI where they fit best. Symbolic analysis for planning logic, maybe probabilistic checks for uncertain inputs, knowledge for explanations, LLM assessment for language. You get the idea.
A tailored toolkit for self-awareness.
Right. And this integrated approach, analyzing the past, evaluating the present, forecasting the future, lets meta-AI move beyond just reacting to errors.
Towards proactive self-management.
Yeah. It can learn, assess its current abilities for a task, predict success, and then adjust. Maybe ask for clarification, simplify the goal, delegate parts to other specialized AIs in the system.
More flexible and robust.
And that ability for detailed introspective tracing, it becomes crucial for trust, gives explainability that simple rationalizations can't. Plus, vital for debugging internally and figuring out accountability when many parts are interacting.
Essential for complex systems.
And looking even further out, modeling that cognitive sense of self, identity, embodiment, that could help meta-AI reason much better about its role, its history, its capabilities, leading to more coherent, predictable behavior overall.
This has been, well, a really deep dive into some fascinating stuff.
Yeah.
It definitely sounds like computational metacognition isn't just theory, it's critical for where AI is going. And listeners can find a summary too, right, in the research.
That's right. Table 1 in the research we looked at gives a nice snapshot, compares different approaches, the mechanism, what triggers it, the goal, potential meta-AI uses, supporting ideas. Helpful overview.
Great. So as we wrap this up, what are the key takeaways on computational metacognition for these future meta-AI systems?
I'd say the main thing is this is a foundational layer. Self-awareness, self-evaluation, proactive problem solving. They're going to be essential for advanced meta-AI.
And it's not one size fits all.
Definitely not. It'll likely be a hybrid approach, combining different models and techniques, looking back to learn, looking forward to anticipate.
And introspection is key for trust.
Absolutely. For trust and accountability in these incredibly complex systems, that ability to explain the why is paramount.
It really does make you think, doesn't it,
Oh,
about what understanding or awareness even means for a machine. And as AI starts reflecting on its own thinking, wow, the ethical, the practical questions just pile up.
they certainly do.
Well, thanks for joining me for this deep dive into computational metacognition. It's been enlightening. Until our next exploration, keep asking those questions.